we're going to jump to section 3, wherein we are going to start calculating. And the first calculation we will do would be unit conversion. All measured quantities consist of a number and a unit. Don't ever forget that. So do not give an answer that just has a number unless that's what it's asking for. Because we are going to be working with measurements, there will always be a unit. When we're converting, we need to construct or use conversion factors, and they are ratios used to express quantity in different units. The conversion factor you choose must cancel all units except those you want in the answer. A ratio is essentially a fraction, or a conversion factor ratio is essentially a fraction that can be flipped because the fraction equals 1. For instance, we know that a mile is equal to 5,280 feet. So we're working with two different units here, and this equality we can turn into a fraction such as this. 1 mile over 5,280 feet is a conversion factor that equals 1. We can also say, we can just flip it. We can flip the denominator and the numerator, wherein we're saying 5,280 feet over 1 mile is an equality because it still equals 1. And with that rationale, we can say that the flipped conversion factors are equal to each other. So 1 mile over 5,280 feet is equal to 5,080 feet, or 5,280 feet over 1 mile. And that's how we will be using conversion factors, is that we will be flipping them. And we do have to make sure that we are using the correct conversion factor, because if we say 1 mile is equal to 5,280 inches, that is not quite true, no matter how we flip the fraction. When we do calculations in chemistry, more often than not, we are going to be working with measurements. And when we talk about measurements, we have to be familiar with the units. In 1960, a committee in France developed the universally accepted SI units, which really would be the metric system. There are 7 fundamental units, or base units, and each of these are identified with a physical quantity. These units are found on the table that we see on this slide. The unit for length is meter. For temperature, it is Kelvin. For electric current, it's ampere. Time, we will be using second. Luminosity, which I don't think we have any calculation that entails or uses this unit, but it is in candela. For mass, which is the only SI unit that uses prefix, it is kilogram. And then for the amount of substance, it would be in mole. And it says here each unit is based on a physical quantity. That is because it's based on something that is physical, and we will be able to take a look at those physical quantities in the next slides. All other units are derived units, and derived units are combinations of the 7 base units. We are familiar, we've seen this before. These are the SI prefixes for measurements, and each prefix will have a number value. For example, we have tera, so the prefix tera will always mean 10 to the 12. And that would be a trillion. And then the prefix giga is always going to be 10 to the 9, or a billion, and so on. So these are the larger units. And then we also have units that are going to be less than 1. We are familiar with the prefix centi, and that will always mean 1 out of 100. Or if we turn that into a decimal, it's going to be 0.01. The prefix milli is always going to be 1 out of 1,000th. So it's going to be 0.001. And then the prefix micro is going to be 1 out of 1,000,000th. And we can see the trend here. Nano will be 1 out of 1,000,000,000. Pico or pico will be 1 out of 1,000,000,000,000. Be able to recognize the smaller units and then the larger units. Before we start with problem solving, first let's figure out how to use this table. In our table, we have our prefixes, and notice how it says 1 quantity. So the number 1 will go with the prefix. And then we have unit and unit on these sides. So what that's saying is that these units can be replaced by any base unit, such as if we're measuring mass, we can replace it with grams. If we're measuring length, it would be meters. Volume will be liters. If we're measuring time, it will be second, and so on. And this will be for both. Okay, for instance, let's say we're working with mega, with a large unit. Let's say we're working with the unit mega. And so 1 mega, let's say we're measuring mass, 1 megagram is going to be equal to whatever that unit mega means. So mega will always mean 1,000,000, and we can write it in exponential form. So it can be to the 6th exponent. And again, these are in scientific notation. So really we have 1 times 10 to whatever power that is. All right, so for mega, it's going to be 1 times 10 to the 6th. So 1 megagram is equal to 1 times 10 to the 6th gram. We can also work with small units. Let's say we have the unit nano. So 1 nano unit is going to be equal to much less than that value because the prefix nano is very small, and it is 1 times 10 to the negative 9th units of that 1 nano unit. So let's say we're measuring 1 nanometer, and that nanometer, 1 nanometer is going to be equal to a billionth of that. So that's going to be 1 times 10 to the minus 9 meters. So that's how we use our table. We look for whatever unit we need to work with or convert from or convert to, and then we figure out the number equivalency. So mega is going to be 1,000,000, nano is going to be a billionth, so that will be 1 times 10 to the negative 9th. And then we have to make sure that the number 1 goes with the prefix, because that's how it's written out in our table. So 1 goes with the prefix, and then whatever base unit we're working with, it has to be the same. So we cannot convert from 1 nanometer to a gram. Now we're ready to work on the sample problem, and we have to convert 5.712 milligrams to kilograms and nanograms. And the method we're going to be using is called the box method. And yes, I do encourage you to use that method because it's going to be the same method we're going to be using for a lot of our calculations, especially for the harder ones such as stoichiometry in Chapter 3. So the first thing we're going to do is to figure out our units. And it looks like we are going to have to convert milligram to kilogram. So we're going to lay out our box method, starting with our given value, which is 5.712 milligrams. I also encourage you to start by the given and then writing a 1. A lot of times when you leave this area blank, you will be tempted to write whatever else there. So putting 1 there will eliminate misplacing any numbers. All right, so we have milligram and our conversion factor. So let's write out our conversion factor to begin with until such time that you get comfortable with this and you don't have to keep doing that. So 1 milligram is equal to the number 1 times 10 to the minus 3rd. gram. And then we have to turn it into the unit kilogram. The same thing. Let's go ahead and write out our conversion factor. So 1 kilogram is equivalent to 1 times 10 to the positive third grams. And so that's what I wrote right here. So then it's a convenient area to look at when we start filling out our table. All right, so how do we figure out what number goes where? We go by the unit. Because we want to cancel out milligram in the numerator, this milligram will have to be in the denominator. So this value right here will have to go in the denominator, so 1 milligram. That leaves this other value to go on to the other empty space, which is the numerator, so that's 1 times 10 to the minus third grams. We can cancel out our unit. But because we don't want grams, we want kilograms, we have to add in another box. The same methodology. Because we want to cancel out grams, grams will also go in the denominator, and then whatever number goes with grams, that's what we're going to write in. So it looks like with grams, it's going to be 1 times 10 to the positive third. Okay, don't make the same mistake that I did. Since we already used this conversion factor, we don't need to use it again. So now we're going to use the other one. So 1 times 10 to the positive third grams is equivalent to 1 kilogram. And then we cancel out our units. All right, when entering this in our calculator, there are several ways you can do this. So you can treat it as you're just multiplying fractions, wherein you can multiply all of the numerator. You can write your number in, divided by multiplication of the denominator, and then write your value in, and then divide at the end. But another way to do this so that you can just enter it in your calculator is to figure out where the numbers that are not going to be 1. And so I have 5 point, let me make sure I'm showing my entire calculator. So we have 5.712, and because the other value that is not 1 is in the numerator, I'm going to go ahead and multiply. Minus third. And then the other value is in the denominator, so then we're going to divide. Divided by 1 to the third, and our answer is this. Okay, also I have a separate video showing the other calculator. So this is what I have. If you have the, I don't quite remember what it is, but if you have the other calculator that most students have, there's a separate video that you can watch if you want to in order to refresh yourself in entering scientific notations. So our answer is 5.712 times 10 to the minus 6, and our unit is in kilograms. If you want maximum points for your assignments, your quizzes, exams, and any assessment, always make sure that you have a numerical value and then your appropriate unit. Okay, we're going to work on the next conversion factor, and I do have a new sheet here so then it doesn't look congested. But we are going to convert the same value, 5.712 milligrams, but this time we're going to convert it to nanograms. And the same methodology, we're going to figure out the units, the prefixes that we need, and then we're going to write out our conversion factors, starting with the prefix milli. And milli is right here, and 1 milligram is equal to the number 1 times 10 to the minus third grams. And then we're also working with nano, so we have 1 nanogram is equivalent to 1 times 10 to the minus 9 grams. So those are our conversion factors. Then we're going to use our box method. Milligram. Again, making sure to write 1 in the denominator so that you're not tempted to fill it in with anything else. And then let's figure out which number goes where. So because we want to cancel out the numerator, this unit milligram, we're going to put this value in the denominator. So 1 milligram. And then the other value goes on top. Okay, so this conversion factor is used. Cancel out our units. Now we're free to use the second conversion factor, and because we want to cancel out grams, we're going to go ahead and make sure that grams will be in the denominator, which is this value, 1 times 10 to the minus 9 grams, which leaves 1 nanogram to be in the numerator. Cancel our units, and all we have to do now is enter this in our calculator. So again, we have 5.712 times 1 times 10 to the minus third divided by 1 times 10 to the minus ninth, and this is our answer. And our unit is in nanograms.